stop ruining your AI agents. We're going to dive into all of the mistakes that can ruin your AI agents' results. By building so many AI agents, I have seen all of the mistakes that can be made that can affect your result drastically. And today I'm going to reveal all of the pitfalls and, more importantly, how to fix them, so you can build AI agents which are suitable for real-world projects. So you can overcomplicate your prompt engineering. What do I mean by that? That you can use excessive and big and complex user prompts without any clear instructions or steps and just hoping that LLM will figure it out. Let me give you an example and show you how to fix this problem. For my training, I'm building AI agents for healthcare, for a complete hospital. And one part of it is a doctor, is a physician. I could say a lot of things. Can you figure out all of these as a doctor? But the best thing to just keep it as a very simple prompt. So the initial prompt, you would say, you're an experienced doctor, start a conversation with patient and give symptoms and diagnosis. But then use tabular data. What do I mean by that is, for example, this data from Kaggle is real measurements from the real patients. You get actually these symptoms and information from a patient. So LLM does not need to just come up with all of those information. We'll gather that and will use them as an input. You kind of make a connection with the real world projects. In real world, a doctor will measure things first, will ask questions, and then will decide actually what's going on with the patient. So that's in the tabular data. What you also could do is using medical imaging vision models. Let me show you. So this kind of images, so you could use, for example, models from Hugging Face to do this pneumonia detection. So if I go to Hugging Face and then I would say X-ray, and then we'll just use this pneumonia detection classification, then we will have a model which is already pre-trained, specialized in that specific kind of industry, which is medical imaging, and can, for example, in this case, go ahead and detect pneumonia versus normal. So in this way, we do not leave everything to our LLM, but use LLM to bring everything together. Another mistake is not testing your tools and agents separately. It means just not look at your integration, your data, your web search, everything agent by agent and tools by tools separately, and just put them together and hope that everything would be all right. Like every data science and AI project, you need to have working elements before you put them in the AI agents part. Let me show you an example. So building AI agents for a hospital, I was building one by one each of the agents, like having just a graph which is just only one agent. Look at each of the tools, each of the function calling, working with images, and looking at each of the functions, which are just basically Python functions, if they are working. And after running that, then looking if it's working as in one agent, go to the next agent, build that the same way, and next agent. And finally, you just put all of the agents together and build actually that final graph, which will like kind of brings everything together. This is the only way that you know for sure that your agents and tools will exactly do what you want them to do and will avoid actually tracing very complicated codes afterwards. The next mistake is not using RAG, Retrieval Augmented Generation. LLMs can have hallucination or outdated or non-transparent information. We don't know how they come up with information and also what kind of reasoning they have used to get to that result. The solution to these problems is Retrieval Augmented Generation, or RAG, because they retrieve information from documents, and these documents can be as recent as we want them. You also have security of your own internal document without leaking it to the internet. And what they use to find the right piece of information inside that text is semantic similarities. And they will compare what you have said and will get the result as you want to. And basically that's the reason that they got adopted So the three main steps in RAGs are retrieval, augmentation, and generation. In the retrieval, you will go and search for relevant pieces and snippets of information. In augmentation, you enhance the quality and relevance of that retrieved information. And finally, you go ahead and craft an accurate response. It will also, on a technical level, look like that. You will hear things like embedding and chunking about RAGs. If you want to understand that better, I have a video on my channel. It's about local RAG for NVIDIA, like a stock advisor. In that video, I will teach you how to build a RAG, use a PDF parser, text splitter, use embeddings, vector databases, and then retrieve it in a multi-query way, and then just have a stock advisor for NVIDIA stock. When you get that, you even can use ElevenLabs to generate the text to speech. So if you want more detail, just go ahead and watch that video. The next mistakes that you can make is ignoring context windows and token limits. So you can feed huge chunks of text or entire document or data as a context window, and considering that model will understand and will take actually everything, but there is always a token limitation. The model cannot accept a complete book or very big database. So let me show you an example of how you can fix it. When I was building CrewAI, a finance advisor for my training, what I wanted is to give credit and debit transaction of a person, real world data, to get some summaries and some financial health situation for that person. But if I feed a whole data set to this personal finance crew, then the whole context window will be exceeded, and then the data will not be understood by any chance. So you cannot pass it. Most of the time it will just stop and give you an error. So what I did is creating this monthly data fetcher tool. So I just created some kind of clustering or just division of my data, and then I feed it one by one, actually, months by months, to LLMs instead of the whole data, which was a number of years. And the context window will not be understood. So thinking clustering or basically dividing your data in pieces without losing the context behind it. Feed it monthly or feed it based on a specific category. In this way, you get results, and most of the time, better results and faster. If you wish to build AI agents for real-world projects and learn a lot about building AI agents with the three best platforms for AI agents, Langgraph, LangChain, CrewAI, and OpenAI Swarm, just check out my training where you will learn without no fluff, very modular and completely hands-on how to build AI agents which are using tabular data, image data, video data. I will combine it into projects like finance, healthcare, aviation, tourism, sales, everything that is used with a lot of businesses. Just a few days after launch, hundreds of people have joined. So I hope that you're also one of them and come and join us. And very soon you will be able to build AI agents for yourself. I see you in the training. The next mistake is failing to use embedding and vector databases correctly. Quality of embedding, vector databases, chunk size, all of that can drastically influence the end results, especially for the retrieval part. Let me show you some examples and how to fix this. In my video about NVIDIA, the local RAG, I gave lots of tips about this, but if I wanted to summarize it, I showed back then, for example, how a nomic embedding text from Ollama was a better embedding than, for example, the fast embedding from LangChain or the Hugging Face embedding. I also showed that ChromaDB and Face both are really good vector databases for most of the use cases. We also saw in a complex PDF, the chunk size and chunk overlap are very important. If you choose this chunk size too small, the context will be just disappearing. If you make it too big, it's just diluted with too much of information. So all of these are important when you need a retrieval for your AI agent. The next mistake is not choosing the right LLMs platforms. For the task or specialization that you have, you can just go ahead and use all of these large language models, like one large language model for everything, but it's not going to work. If you give coding to Mistral, you're going to have a problem getting any good answer from that, because Mistral is really good for any creative work. If you have anything of reasoning, OpenAI, almost all of the models do great job, and Llama is very versatile and it gives you different answers. But you have lots of small and specialized models on Hugging Face, but also platforms like Grok, which speed up your process, or Ollama, when we basically can do everything locally. So the combination of LLMs and platforms are really important. Let me show you some examples on Hugging Face. For a part of my training, I needed something like a gender classification. So what I did, I came here and asked, okay, I want a gender classification model. Then I could get this model here, which just gives you gender classification. I could see that the number of downloads are very high, and that's just kind of immediately gives me a very small model that already has been pre-trained with the right data, and then I can use it, for example, on a website, on a picture, and then show if we are talking about a male or female. And that's, for example, for identification. You go to a hospital or to airport, and this is where you can think of any tasks like image to text. If you go to Hugging Face, to models, you can see lots of tasks. But if you, for example, we can say we want image to text, then you can get lots of models and you can try. And the number of downloads here, it will immediately give you actually how good a model is. So I really encourage you to take a look at everything on Hugging Face. I have a 15 minutes tutorial. It's a beginner's tutorial for Hugging Face. If you have never been on Hugging Face, just watch that. In Hugging Face, in just a few lines of code, you can do lots of magic. So it would be really worth your time to invest in Hugging Face and have it, like I said, tool in your AI agent building bag. Another mistake that you can make is skipping performance optimization. This can be really killing. Nobody will like actually AI if they have to wait for an answer for about 20 minutes. Everybody wants the answer fast, and that's where Grok and Ollama come to picture. They are different. I'm more a fan of Grok. The speed is way higher than Ollama, but Ollama can also do a lot of things locally. The way Grok works is that they have this tensor streaming processor architecture, or TSP, and that enables deterministic data flow and in this way minimize actually latency. They also use speculative decoding, which is very impressive. For example, for Llama models, from 250 tokens per second to 1660 tokens per second. And they also have this automated compiler, which is adding to that speed. Ollama use more hardware utilization, so the kind of using modern GPUs and CPUs. It will also allocate the resources in an adjusted way. So it will be looking at the configuration, it will adjust actually the memory and CPU. It's famous for is the model optimization. We just reduce the size of the model and make it smaller. And we use quantization or fine-tuning. Let me show you Grok and Ollama on their websites. So if you have seen my video, or if you have followed my training, you can see that I'm using Grok Cloud. If you go to model, you can see we have a lot of models. And right now, one of the latest model is the Llama 3.3, 70 billion versatile. So this is where you can find actually which kind of models are under Grok, and Grok is console.grok.com and it's Grok Cloud. Remember, Grok with a K is completely different. It's a model from Elon Musk, but Grok is more a platform for speed and performance. And you can see also at the right side that we have also vision model. As you can see, the vision model preview 90 billion. If you go to Ollama, then you can see Ollama have a number of models. If you click on it, also Llama 3.3, the Llama 3.2 Vision, Mistral, also this Nomic embed text is one of the most famous and best embedding. Then we have Qwen, which is also very famous, Qwen 2.5, which is also pre-trained on Alibaba's latest large-scale data set and 18 trillion tokens. My advice would be definitely leverage one of these two, especially Grok. This mistake can just also cost you a lot of time. Letting LLM arrange repeated tasks for agents. So if you give any kind of counting to an agent that's supposed to do the same task for different entrees for different people, most of the time will end in infinite loop, non-ending countings. The reason for that is that LLMs are really bad in basic mathematics kind of things. They are really good in fuzzy, but they're not so good in abstract. So, for example, they would go first person, second person, and we'll go to the third one, and they would say, oh, again, first person, then they will go to sixth person. So it's just all over the place. But let me show you what I mean by that. For my training, the part that I use OpenAI Swarm, I'm building an entire airport. And then you will have, of course, an agent which is a passport control agent, right? You will always have a passport control in your airport. So here you have to pass actually those people. And what I did was I just said, okay, I have an agent, which is a passport control agent, which I defined what you should do and the messages and the context variables. And then I would just use a for loop. So just programming it with simple Python, and I will count the next passenger and use context variable to pass it to LLM. So don't just let LLM count. And then we'll just go ahead and say, okay, first person, next person, and the next person. And that's how you manage this actually. The next mistake is ignoring text-to-speech. Speech and audio brings that human-like feeling to any agent that you're using. It's also kind of finishing touch. They can add another layer of liveliness to your application. ElevenLabs is by far the most famous in the world, and you have a number of other text-to-speech. I've written an article on LinkedIn. Let me go to post. I'll find it for you. I think this is it. Yeah. So we have the top 10 text-to-speech here, and each of them has their own advantage and disadvantages. I copied the link and you can just read that. But this one, for example, is an open source platform. So Play It has also a very good name next to ElevenLabs. But let me show you this Coco TTS on Hugging Face. If you go to Hugging Face, to models, then you go to audio, text to speech, and you can see here 1.85 million downloads. So this one, and if you look at everything, you can see that this is actually a good text to speech. For English, Spanish, French, German, Italian, Portuguese, Polish, Turkish, Russian, Dutch, Czech, Arabic, Chinese, Japanese, Hungarian, Korean, and Hindi. And if you go here, you can see there is a space. You can basically just check the...
Spaniola was rolling scuppers under in the ocean swell. The booms were tearing at the blocks, the rudder was banging to and fro, and the whole ship creaking, groaning and jumping like a manufactory.
As you can hear, this is very nice voice. So in general, they can be very AI sounding. And that's why ElevenLabs is just very distinguished in that. But this one is also really great. In my video about ElevenLabs on my channel, I just go inside how you can reach ElevenLabs, but I can show you the code very fast, how you can build and add that layer to your rack. For example, you can use just ElevenLabs directly, ElevenLabs client, import that. Then for English, you can use this 11 Turbo 2 and just pass your text here, choose the model, and you can then also even add any voice if you want. And then you can, for example, write it down to an MP3. Imagine that you have something which is not English. What you would do is use another model, which is 11 multilingual version 2. If you want a more deep dive on how I just do AI agents with LangChain, watch that video. The next mistake is not using prompt templates and context variables. If you hardcode your prompts inside your code, you have to rewrite them for every version, and it's just not going to work because every situation will going to be different. As same as every data science as before, we need actually to give some variables. So using those dynamic variables as function callings or search and added to those prompts, making prompt templates, will actually add a lot of value and flexibility to your agents. Let me show you some examples. From different platforms now, we have LangChain, Langgraph, CrewAI, and Swarm. Swarm called it context variables, which is really a beautiful name for actually using this kind of dynamic variables. So what you do is you just give a context variables to your agent. In this case, if we have an agent which is a contact agent for some kind of hiring and vacancy, then instead of just hard coding, you can just give the candidate name, vacancy, and then progress, and pass it on to your agent as context variables, which makes it really flexible and dynamic. Let me show you how it is done in CrewAI. You're building like an agent, you use it as an input variable, and when you write your description, which is like that prompt or prompt template, you would just pass on that. For example, here we want an investment advice based on an investment advisor on YouTube. So we will give the YouTube channel name to our agent, and then it will search there, just summarize and gives us some do's and don'ts about investment. And if I want to take a look at that for LangChain, we even can pass an entire data frame and data set to our agent that will use actually as some kind of function or tools instead of going and finding and searching for it, because that becomes a little bit fuzzy. And in Langgraph, we have nodes and edges. And what you do is next to that agent, always pass on all of the variables that you need. And this is the way that you just kind of create a node with all of those variables or tools connected to it. And that's why the prompts become very simple. You basically have an initial prompt, and anything else is that node which is connected to all of the necessary components that they have. So we have a node, and that node or that agent will have all of the variables that they The next mistake that you can make is not leveraging flow engineering. When we are working with any project, you will have a goal, and we want to achieve that in step-by-step manner. Most of the time, we don't think in nodes and edges, we don't think in agents, we don't think in tasks, but we think in the steps that we have to get there. If you want to prepare coffee, you just think of the small steps that you need to do, taking the mug, putting the coffee cup in the machine and just pressing the button. It's not that different for a very complex project. And how more the platform, the frameworks that you're working with when building AI agents leverage flow engineering, how more intuitive it is for you, how less of mistakes you're gonna make. In my training, the part of CrewAI, because they have just leveraged like flow engineering really good, and it calls also flow, I built also flows. Let me show you an example. So in the flows in CrewAI, you will just kind of go through a pipeline of flows. You will start and you will listen to the next one, then to the next step. And if the previous one is done, you will go to the next one and next one. And if you even visualize it, it will look like as, okay, I have an input. Do I have enough information to go to the next one? And finally, can I use all of those previous steps to bring them together, summarize them, and just give a result? That's actually how flow engineering is working. And utilizing this is going to help you a lot. The next mistake is not leveraging DPR next to RAG. When building AI agent, you use LLMs, you would use anything like a LangChain or CrewAI or OpenAI's farm. But as I mentioned, you can also use these retrieval methods. A lot of people know about RAG, but they do not know that much about DPR. DPR, or dense passage retrieval, is a method for retrieving relevant documents or passages from a large corpus, particularly in the context of question answering tasks. So DPR working these dense vector representations, so these embeddings, very similar to RAG, also work with semantic similarity. It's surprisingly effective, extremely fast. It has this question encoder and passage encoder to extract actually the piece of information that will be necessary for you, and will speed up the process because it will focus on what's necessary for you to retrieve. Of course, will avoid hallucination. In one of the videos in my channel where I'm building talking AI multi-agent from YouTube videos with Ollama, LangChain, ElevenLabs, Llama 3, let's say Hugging Face, CrewAI, I will kind of use it for first-time traveler to Amsterdam. I will go through the steps of building that. So if you want, just take a look at that one. So the way I would look at this is how it's searched, how it's summarized, how you can use Face, which is same as ChromaDB, a very good vector database to find and search the relevant information, and finally summarize it and get that back to anything. And you can use CrewAI. So dive into that video to see how I do that with CrewAI, LangChain, and ElevenLabs.